Hello everyone, my name is Dr. Saurabh Tripathi and you are watching my YouTube channel EE Lectures. In this video, I will clarify the answers to a few multiple choice questions related to the DC machines. So let us look at the first question. Lap winding is suitable for. The options are high current and low voltage DC generator, low current and high voltage DC generator, low current and low voltage DC generator, high current and high voltage DC generator. As we know, the number of parallel paths in case of lap winding is always equal to the number of machine poles, and therefore the total armature current is equally divided among these parallel paths. Obviously, for this reason, the lap wound armatures are generally used in large DC machines having high current and low voltage ratings. Hence, the first option is the correct answer. Next question is, the sole purpose of a commutator in a DC generator is to. The options are increase output voltage, provide smoother output, convert the induced AC into DC, reduce sparking at brushes. We have already learned that the EMF induced in the armature conductors of a DC generator is of alternating nature. However, by means of a commutator, the current in the external circuit becomes unidirectional. Therefore, the sole purpose of a commutator in a DC generator is to convert the induced AC in the armature conductors into DC. Hence, the third option is the correct answer. Next question is, the DC armature winding in which coil sides are a pole pitch apart is called. The options are fractional pitch winding, full pitch winding, lap winding, wave winding. Now look at the illustration of full pitched and fractional pitched coils. If the pole pitch and coil pitch are equal, the coil is called full pitched. Otherwise, it is called a fractional pitched coil. In the given question, the coil sides are a pole pitch apart. This means the DC armature winding is a full pitched winding. Hence, the second option is the correct answer. Next question is, the series field of a short shunt DC generator is excited by. The options are shunt current, armature current, load current, external source. Now, look at the illustration of a short shunt compound DC machine. Here you may notice that the load current flows completely through the series field winding. Clearly, the series field of a short shunt DC generator is excited by the load current. Hence, the third option is the correct answer. Next question is, in a DC machine, the number of commutator segment is equal to. The options are number of conductors, twice the number of poles, number of coils, twice the number of coils. As illustrated in this figure, one may notice that the two ends of a coil are connected to two different commutator segments. Moreover, each commutator segment connects two coils. Clearly, the number of commutator segments is essentially equal to the number of coils. Hence, the third option is the correct answer. Next question is, a 4-pole lap wound generator has 280 conductors, the EMF induced per conductor being 5 volt. The voltage generated will be, the options are 70 volt, 350 volt, 1400 volt, 1120 volt. For lap wound generator, the number of parallel paths is equal to the number of machine poles. Therefore, A is equal to 4. Now, as can be noticed from the illustration, the voltage generated by a DC generator would be equal to the voltage across any parallel path. So, we have to find the voltage across a parallel path only. Here, the number of conductors is equal to 280. So, the number of conductors per parallel path will be 280 divided by 4. This comes out to be 70. Since the EMF induced per conductor being 5 volt, therefore, the voltage across each parallel path will be 5 multiplied by 70. This comes out to be 350 volt. This way, the voltage generated by the DC generator will also be 350 volt. Hence, the second option is the correct answer. Next question is, the efficiency of a DC generator means its. The options are electrical efficiency, commercial efficiency, mechanical efficiency, electrical efficiency over mechanical efficiency. Actually, this is a very simple question. Unless stated otherwise, the efficiency of a DC generator always refers to its overall or commercial efficiency. Hence, the second option is the correct answer. Next question is, a DC motor when connected directly to the supply would draw a very heavy current because the options are the back EMF at starting is the maximum, the back EMF is opposing the supply voltage, the back EMF at starting is 0, the torque required at starting is very high. Just consider the case of a separately excited DC motor as an example. The terminal voltage, back EMF and armature current are related by the equation Vt is equal to Eb plus Ia Ra. We may rewrite this equation as Ia is equal to Vt minus Eb over Ra. Clearly, a DC motor connected directly to the supply would draw a very heavy current at the time of starting when the back EMF is 0. Hence, the third option is the correct answer. Next question is, for building up voltage, residual magnetism is essential in field systems of all types of DC generator except. The options are compound DC generator, series excited DC generator, separately excited DC generator, shunt excited DC generator. This is also a very simple question. In case of separately excited DC generator, the field system is essentially required to be excited by an external DC source. On the other hand, the self-excited DC generators do require the residual magnetism in their field systems for building up voltage. Hence, the third option is the correct answer. Now the last question is, a 440 volt DC shunt motor has an armature resistance of 0.8 ohm and a field resistance of 200 ohm. What will be the back EMF when giving an output of 7.46 kilowatt at 85% efficiency? The options are 222.4 volt, 392.7 volt, 312.6 volt, 425.8 volt. Since the motor is delivering an output of 7.46 kilowatt at 85% efficiency, therefore, the input power to the motor will be 7.45 multiplied by 1000 over 0.85. This comes out to be approximately 8.78 kilowatt. Now, the input current to the motor can be calculated by dividing the input power by the input terminal voltage. So, the input current to the motor, that is IL, comes out to be 19.95 ampere. Further, shunt field current ISH can be calculated by dividing input terminal voltage by RSH, which comes out to be 2.2 ampere. So, the armature current IA will be IL minus ISH. This way, IA is calculated 17.75 ampere. Now, recall the current voltage relationship for DC shunt motor. We have back EMF EB is equal to Vt minus Ia Ra. Substituting the values of Vt, Ia and Ra, we obtain the value of back EMF equal to 425.8 volt. Hence, the last option is the correct answer. That's it for now. Keep watching and do like this video and subscribe to my channel. Please don't forget to share your learning experiences on this short video. Thanks for watching. Goodbye.